So we're doing 4.1 part 2, and today we're going to look at more quadratic equation stuff. So what we've found so far is that with this particular equation, it's quadratic because the highest power is 2, but we can't do the quadratic formula because it's not equal to 0. So we're going to fix that situation. The way you fix that situation is you're going to move everything from one side to the other. Now, technically, it doesn't matter if you move the stuff on the left to the right or the stuff on the right to the left, but usually there's like a better choice that can avoid negatives and stuff like that. So it doesn't matter, though. You should end up with the same answer regardless. I'm going to choose to do this. I'm going to move the 3b squared. I'm going to subtract it off of this side. And whatever you do to one side, you have to do the other. And when I do that, I'm going to line it up with the term that it goes with. So they're both b squared, so I'm going to put those together. I also want to get rid of this 5, so I'm going to add the 5. And which one would I put that with? The 2. Yeah, negative 2. And now we're just going to see what's left. So here we have 6 take away 3 is 3b squared. Bring down your 4b. That one didn't change. Negative 2 and 5. I'll draw an arrow. Negative 2 and 5 makes 3. And now it equals 0. And now we can do the quadratic formula. Okay? Now, I also picked this problem because it's going to show us something you guys didn't see yesterday. So you'll get to see it today. But for now, I'm just going to kind of go through the steps of what we talked about last time. To find b, you're going to do the quadratic formula. So b is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. A is 3, b is 4, c is 3. So we're going to plug that in. Put a 4 here, 4 here, 3 here, here, and here. All right. We're going to simplify our 4 parts that we talked about yesterday. So that one, that one, that one, and that one. Yep. So this is A, and this is C. Both of them are 3. All right, so we simplify those 4 parts, and we'll have the following. I'm going to stop there, make sure you guys are finished writing, because this is where the new thing comes in. I want to make sure you guys are ready for that. So let's begin the new part. The next thing that we did yesterday, we took care of this guy here. And what I've encouraged you guys to do is just to kind of do that off to the side. So I'm going to do that over here. All right, so 16 take away 36 is negative 20. Now, I don't know if you guys remember this, but with square roots, you can't take the square root of a negative number. Like, for instance, the square root of 9 is 3, because 3 times 3 makes 9. But a negative, that's not possible. Okay, because anytime you multiply a number by itself, it has to be positive. Whether it's 2 positives or 2 negatives, it's always going to be positive. So it's impossible to take a square root of a negative and get a real answer. And so what we have here is this is an imaginary number. So I would write a little note here, and I would say if the number under the square root is negative, what we're going to do is we're going to cross off the negative and put an I in the front. Now, I'm not going to go into a lot of the detail about imaginary numbers today. That's something that hopefully you kind of had a little bit of experience with in algebra 2. But basically, an imaginary number, the square root of negative 1 is I. That's an imaginary number. So anytime you have the square root of a negative, it creates what we call a new type of number called an imaginary number. It doesn't mean that it's mythical or, dragons know all about it and, fairies and things. It's just another type of number in math, and they call it imaginary. So what we're going to do is when you see a negative on the inside, put the I in front, and that means, okay, we're gonna treat that like an imaginary number. Okay.
Oh, so you just put the I in front.
Yep.
Like so.
Yep. Just cross off the negative and put an I in the front. Now that means something, by the way. That means that this equation does not have a real answer to it. We're going to have an imaginary answer, but it doesn't have a real answer. Once again, it doesn't mean it's a mythical answer. It just means the answer is a different kind of number than the real number system we're used to. Okay? So, the next thing we do is after that, guys, there's really nothing else new. The square root of 20, you would break it down into its prime factors. And I don't think I told you guys this story. Did I tell you the turtle story yesterday? I don't think I did. So, for square roots, I like to tell a story. It helps people remember how to do square roots. So, before I begin the story, I'll tell you how turtles work. I watched a documentary one time. And on this documentary, I saw that the turtles lay all their eggs in the sand, and then they leave. And then the little turtles have to, when they hatch, there's no parents there. They just have to scamper their way to the ocean. And unfortunately, most of them don't make it because, like, seagulls come along and pluck them up. It's very sad. Very sad. So anyway, I felt like this had something to do with square roots. And so I'm going to tell you my turtle story. Okay, turtles are not great parents. They leave their babies to fend for themselves. So you see, as you guys know, when a mommy turtle and a daddy turtle love each other very much, they have a baby turtle that looks just like them, and then they leave. Okay, so that'll help you remember your square roots, the turtle story. All right, so there it is. Now we have the I there because it's an imaginary number. So the turtle story was new, but the way you take square roots is old. We did that already. But the I thing, that's the new part I really want you guys to know. So we have this now. B is equal to negative 4 plus or minus 2I square root 5 over 6. Does anybody know what the next step is? Yeah? Simplify. Now, what do you mean by simplify? We can reduce all the numbers outside the square root by something, right? All 3 of these can be reduced by 2. And that's also something that we did yesterday, I believe. So negative 2 plus or minus. Now, for this one, we don't need the 2. Well, 2 divided by 2 is 1. You could put 1I, but anytime you have a variable or something with a 1 in front of it, you don't need to write that. So we could just put I root 5 over 3. And there you guys go. So once again, that means this doesn't have a real solution, but it has imaginary solutions. All right. So let you guys try one of them. Yeah, it's not going to go. I'm just putting the new equation up. But here is your problem if you're ready. Go ahead and see if you guys can do that. It's the same thing. You should end up with an imaginary solution. And it's also the same thing where you have to get it to equal 0 first. Okay? So that's the answer there. Anybody still writing that or got any questions? That's the end of the quadratic formula discussion. I'm going to show you guys another type of quadratic equation here. And I would encourage you guys to write down this note. And after you're done writing down this note, I would write down the problem. If we have ax squared plus c equals some number, just get x by itself. So write that note and then write number 1, and I'll explain what I mean by that. Okay. So this is a quadratic because my highest power is a 2. I can't do the quadratic formula right now because it's not equal to 0. But you guys know maybe I could just add this 5 over. And once it's equal to 0, you actually could do the quadratic formula. Don't do this, but I just want to show you something real fast. So let's say you did that. Is that A, B, or C? That's A because it's in front of the square. What's this guy? That's the C. There's no B. And when that happens, that means B equals 0. So you could do the quadratic formula. It'll give you an answer. But I'm going to show you a different way to solve these. And why would we want a different way? Because it's faster. That's really the only reason why. So if you ever come across a problem where there's no B, there's just a square. There's just a K squared, but there's no K in there anywhere. This is the method I would encourage you guys to go with. Just get the K by itself. So if I want to get K by itself, I bet you guys could just mathematically, intuitively tell me what to do. What would I do first to get K by itself? Yeah, we would start by adding 9. Then what would I do? Yeah? Divide what?
Everything by 4?
We're going to divide by 16. We want to get K by itself, so I'm going to cancel out the 16. Now I'm going to reduce that fraction. 4 over 16, what does that reduce to?
How do you do a quadratic function with fraction?
What, Angel?
How do you do a quadratic function with a fraction?
Good. Well, okay, so we're not going to do the quadratic formula with this. We could, but we're not going to. What we're going to do is, how do I get rid of that square? We're going to square root it, right? Do the square root. Now, something to keep in mind is when you do this, those cancel. And, important thing to remember, you get a plus and a minus when you do that. Okay? Now, that's a hard thing to remember, but you do. You get a plus and a minus. I'll give you an explanation why that is, but you don't need to write this. But let's just do something that's not as confusing looking. If I told you something to the second power is 9, and I asked you what's the answer, a lot of you guys would just say, what? What number to the second power is 9?
Oh.
3 is, right? But there's another one. Negative 3. Negative 3 times negative 3 also makes 9. So when you solve these by taking square roots, you always get a positive and a negative answer. So I showed you with a number that's not as confusing, but the same principle applies here. When you solve by taking a square root, you get a plus and a minus. All right. Now, something else is whenever you're taking the square root of a fraction, that was your question there, Angel. How do you take the square root of a fraction? Well, you take the square root of the top and the bottom separately. That's it. So, what is the square root of 1? And what's the square root of 4?
2.
And there's my answer. So the answer is plus and minus a half. So,
Oh, that's weird. The value increases.
yeah, you're right. Yeah, that's true. Good obs. But yeah, I think that's a lot easier than the quadratic formula. Like I said, you could get this thing to equal 0, find your A, B, and C, and use quadratic formula. It'll work, but I don't think it's very helpful. So let's go ahead and take a look at a student practice problem. see how you guys do with that one. I'll give you a little bit of time. So, Michael, what did you do first? Thank you. That is right. All right. Danya, what did you do next? Yeah. Max, what did we do next? And Josh, why is my answer not complete right now? Kramer. I think it's Kramer. Yeah, Kramer. Plus and minus. So the answer is plus and minus 7. Okay. We're gonna look at another one now. And although I still think this is easier than the quadratic formula, this one is a little bit uglier to deal with. Okay. So let's go ahead and work this. So as you guys know, we're going to start by subtracting. I probably should wait for you guys to write. I'll wait for you to catch up with me. All right, so we start by subtracting. Next we divide. And then we're going to take square root on both sides. Now, before I take the square root, I'm just going to put my plus and minus here, but sometimes your square roots don't come out so nice. Okay? So let's break that down. I'll show my work here on the side real quick. And I'll put my final answer there when I'm done. But we have the square root of 20. And once again, you could have negatives in there, so you might have to take out an I sometimes. But in this case, I don't. So we just need to break it down. 4 and 5. 2 and 2. So I've got 2 times 2 times 5. And I've got one pair that can come out there. And that's my answer. All right. See how you guys do with that. No, we can only do this because there's no b.
Oh,
yeah, if you have the ax squared plus c type problems, that's when you do this. What did you do first? No? Okay. Megan, what did you do first? All right, cool, thank you. Timothy, what did you do next?
For what? Oh, I divide by 4.
Uh-huh. Jan, what's next? I'll put my answer there as soon as we figure out what that is. Kimberly, when you broke down the square root of 68, what did you get for the numbers? No? Esteban, how about you? What did you get when you broke down 68? So the 2 can come out, and that's as good as it gets right there. All right. I had one more I wanted to do with you guys. I think we'll stop there though in the interest of time because we get out of here at 2 or 10:55. So we'll stop there for today. I've already gone around and checking notes, so you guys are good. And I will see you guys for the rest of your day. There you go. See you, bud.